OSHA does not specifically mandate flame-resistant clothing for all electric utility workers. However, OSHA requires employers to provide flame-resistant clothing to employees exposed to electrical hazards. The National Fire Protection Association, or NFPA, recommends that all electric utility workers wear flame-resistant clothing at all times when working on or near energized electrical equipment. This encompasses tasks such as switching and disconnecting operations, energized equipment maintenance, equipment testing, and work on energized overhead lines. For boiler operators and maintenance workers who perform lockout and tagout procedures on electrical equipment, certain requirements apply. NFPA 70 requires flame-resistant clothing when working on or near energized electrical equipment rated 50 volts or higher. OSHA 29 Code of Federal Regulations 1910.269 requires employers to ensure that workers are trained and protected from electrical hazards. This includes providing flame-resistant clothing when necessary. For switching in 120 kV yard mats, NFPA 70 mandates flame-resistant clothing for all workers performing switching operations on energized equipment rated 50 volts or higher. It's recommended to wear flame-resistant clothing at all times when performing tasks involving exposure to electrical hazards, including switching operations in the 120 kV yard mats and lockout and tag-out procedures on electrical equipment rated 50 volts or higher. Employers should provide the appropriate flame-resistant clothing and ensure proper training on its use and maintenance. Understanding the nuances of these regulations is crucial for maintaining a safe working environment for those in the electric utility industry. The regulations surrounding flame-resistant clothing, or FRC, are multifaceted and depend heavily on the specific tasks being performed and the potential hazards involved. Let's delve deeper into the key aspects of these requirements. Firstly, it's essential to understand that OSHA's stance is performance-based. While they don't explicitly require FRC for every electric utility worker, they mandate its use when workers are exposed to electrical hazards. This means employers must assess the potential risks in the workplace and provide appropriate protective equipment, including FRC, when necessary. Secondly, NFPA 70E plays a significant role in shaping industry best practices. While not a legal requirement in itself, NFPA 70E is widely recognized as the consensus standard for electrical safety in the workplace. Its recommendations, including the use of FRC for all work on or near energized equipment, are often adopted by employers to ensure a high level of safety. Thirdly, the specific requirements for boiler operators and maintenance workers highlight the importance of task-specific risk assessment. Lockout and tag-out procedures, while designed to de-energize equipment, still carry the risk of accidental energization. Therefore, NFPA 70E mandates FRC for these tasks when working on equipment rated 50 volts or higher. Fourthly, the mention of switching in 120 kV yard mats underscores the high-risk nature of high-voltage work. The potential for arc flash and other electrical hazards is significantly greater at these voltages, making FRC a non-negotiable requirement. Fifthly, proper training on the use and maintenance of FRC is just as important as providing the clothing itself. Workers need to understand how FRC protects them, how to properly wear and care for it, and when it needs to be replaced. Without adequate training, the effectiveness of FRC can be compromised. In summary, the decision of when to wear flame-resistant clothing is not always straightforward. It requires a thorough understanding of OSHA regulations, NFPA 70E recommendations, and the specific hazards present in the workplace. Employers have a responsibility to conduct risk assessments, provide appropriate FRC, and ensure that workers are properly trained. Workers, in turn, have a responsibility to follow safety procedures and use FRC as required. Remember that electrical hazards can be deadly. Taking the necessary precautions, including wearing FRC when appropriate, is essential for protecting yourself and your colleagues. When discussing flame-resistant clothing requirements, it is important to consider several factors that contribute to the overall safety and compliance within the electric utility industry. These factors include the specific tasks being performed, the potential hazards present, and the relevant standards and regulations that govern the industry. Firstly, the type of work being performed is a critical determinant in assessing the need for flame-resistant clothing. Tasks such as switching and disconnecting operations, energized equipment maintenance, equipment testing, and work on energized overhead lines inherently involve a higher risk of electrical hazards. These hazards can include arc flashes, which are sudden releases of electrical energy that can cause severe burns, injuries, and even fatalities. In such cases, flame-resistant clothing is essential to provide a protective barrier against these potential hazards. Secondly, the potential hazards present in the work environment must be carefully evaluated. This evaluation should consider factors such as the voltage level of the equipment being worked on, the potential for short circuits or ground faults, and the presence of flammable materials. A thorough hazard assessment will help determine the appropriate level of protection required, including the type and level of flame resistance needed for the clothing. Thirdly, adherence to relevant standards and regulations is crucial for ensuring compliance and maintaining a safe working environment. OSHA regulations such as 29 Code of Federal Regulations 1910.269 provide a framework for protecting workers from electrical hazards. Additionally, industry standards such as NFPA 70 offer detailed guidance on electrical safety practices, including the selection, use, and maintenance of flame-resistant clothing. Employers should familiarize themselves with these standards and regulations and implement appropriate policies and procedures to ensure compliance. Fourthly, proper training and education are essential for ensuring that workers understand the importance of flame-resistant clothing and how to use it effectively. Training programs should cover topics such as the hazards of electricity, the proper selection and use of flame-resistant clothing, and the importance of regular inspection and maintenance. Workers should also be trained on how to respond in the event of an electrical incident, including how to extinguish flames and provide first aid. Fifthly, the selection of flame-resistant clothing should be based on a comprehensive understanding of the hazards present and the level of protection required. Flame-resistant clothing is available in a variety of materials and styles, each offering different levels of protection. Employers should consult with qualified safety professionals to determine the appropriate type of clothing for their specific work environment. In conclusion, the decision of when to wear flame-resistant clothing should be based on a thorough assessment of the risks involved, adherence to relevant standards and regulations, and the provision of proper training and education. By taking these steps, employers can create a safer working environment for their employees and minimize the risk of electrical injuries and fatalities. Continuing our discussion on flame-resistant clothing, let's delve into more specific aspects of OSHA regulations, NFPA 70E standards, and practical considerations for implementation. OSHA, while not explicitly mandating FRC in every scenario, operates under the principle of the General Duty Clause. This clause requires employers to provide a workplace free from recognized hazards that are causing or are likely to cause death or serious physical harm to employees. In the context of electrical work, this means employers must assess the potential for arc flash and other electrical hazards and take appropriate measures to protect their workers. This often includes providing and requiring the use of FRC. NFPA 70E, as the consensus standard for electrical safety, provides detailed guidance on how to comply with OSHA's General Duty Clause. It outlines specific requirements for hazard assessment, risk control, and personal protective equipment, including FRC. NFPA 70E uses a hazard risk category system to determine the appropriate level of FRC for different tasks. This system considers factors such as the voltage level, the type of equipment being worked on, and the potential for an arc flash. The hazard risk category is used to select FRC with an appropriate arc rating, measured in calories per square centimeter. The arc rating indicates the amount of heat energy the clothing can withstand before causing second-degree burns. Now, let's talk about practical considerations for implementing an FRC program. Firstly, it's crucial to involve employees in the process. Workers who understand the reasons behind the requirements and have input into the selection of FRC are more likely to comply with the program. Secondly, consider the comfort and fit of the FRC. Clothing that is uncomfortable or ill-fitting is less likely to be worn properly. Look for FRC that is breathable, lightweight, and allows for a full range of motion. Thirdly, establish a clear policy on the use, care, and maintenance of FRC. This policy should outline when FRC is required, how to properly wear and care for it, and when it needs to be replaced. Fourthly, provide regular training on the hazards of electricity, the importance of FRC, and the proper use and care of the clothing. This training should be interactive and engaging, and it should be reinforced regularly. Fifthly, conduct regular audits to ensure that the FRC program is being followed and that the clothing is in good condition. Address any deficiencies promptly. In addition to these practical considerations, it's important to stay up to date on the latest regulations and standards. OSHA and NFPA 70E are updated periodically, so it's essential to stay informed of any changes. Also, consider consulting with a qualified safety professional to ensure that your FRC program is comprehensive and effective. Remember, the goal of an FRC program is to protect workers from the potentially deadly hazards of electricity. By following these guidelines, you can create a safer working environment for your employees and minimize the risk of electrical injuries and fatalities. Let's further clarify the nuances of OSHA's stance and the guidance provided by NFPA 70 regarding flame-resistant clothing. While OSHA doesn't provide a blanket statement requiring FRC for all electrical workers, their regulations, specifically 29 Code of Federal Regulations 1910.132, mandate the use of personal protective equipment, or PPE, whenever hazards are present. This is a crucial point. Employers are required to conduct a hazard assessment to determine if electrical hazards, such as arc flash or electric shock, exist in the workplace. If these hazards are identified, then PPE, including FRC, becomes mandatory. The key here is the hazard assessment. It's not a matter of simply deciding whether or not to require FRC. It's a matter of systematically evaluating the workplace to identify potential electrical hazards and then selecting the appropriate PPE to mitigate those hazards. NFPA 70 provides a framework for conducting these hazard assessments and for selecting the appropriate FRC. It uses a table-based approach to determine the incident energy exposure for various electrical tasks. Incident energy is the amount of heat energy that a worker could be exposed to during an arc flash. Based on the incident energy level, NFPA 70 specifies the required arc rating for the FRC. The arc rating is expressed in calories per square centimeter, as mentioned earlier. It's important to understand that the arc rating is not the only factor to consider when selecting FRC. Other factors, such as the fabric's breathability, comfort, and durability, are also important. Workers are more likely to wear FRC that is comfortable and allows them to perform their jobs effectively. Now, let's address a common misconception. Some people believe that FRC is only required for high voltage work. This is not true. Arc flash hazards can exist at any voltage level, even at relatively low voltages such as 120 volts or 208 volts. The severity of an arc flash depends on several factors, including the voltage, the available fault current, and the distance from the arc. Therefore, it's important to conduct a hazard assessment for all electrical tasks, regardless of the voltage level. Another important consideration is the layering of clothing. NFPA 70E allows for the layering of non-FR clothing under FRC, provided that the non-FR clothing is made of natural fibers such as cotton or wool. Synthetic fabrics such as polyester can melt and cause severe burns if exposed to an arc flash. Finally, it's important to remember that FRC is just one component of a comprehensive electrical safety program. Other components include safe work practices, lockout/tagout procedures, and qualified electrical workers. By implementing a comprehensive program, employers can significantly reduce the risk of electrical injuries and fatalities. To elaborate further on the crucial aspects of arc flash hazard assessment and the selection of appropriate flame-resistant clothing, let's consider specific scenarios and delve into the practical application of NFPA 70 guidelines. Imagine a scenario where an electrician is tasked with opening a 480-volt motor control center to troubleshoot a faulty motor. According to NFPA 70E, this task requires a hazard assessment to determine the potential for an arc flash. The assessment would consider factors such as the available fault current at the motor control center, the working distance of the electrician, and the type of equipment being worked on. Based on these factors, the assessment would determine the incident energy level, which is the amount of heat energy the electrician could be exposed to during an arc flash. Let's say the assessment determines that the incident energy level is 4 calories per square centimeter. According to NFPA 70E, the electrician would need to wear FRC with an arc rating of at least 4 calories per square centimeter. This could include an arc-rated shirt, pants, and a face shield. In addition to the FRC, the electrician would also need to wear other PPE such as insulated gloves and safety glasses. Now, let's consider another scenario where a technician is performing routine maintenance on a 120-volt lighting panel. While the voltage is lower, there is still a potential for an arc flash. The hazard assessment would need to consider the available fault current at the panel and the working distance of the technician. Let's say the assessment determines that the incident energy level is 1.2 calories per square centimeter. In this case, the technician might be able to wear FRC with a lower arc rating such as 1.2 calories per square centimeter. However, it's important to note that NFPA 70E requires a minimum arc rating of 4 calories per square centimeter for most electrical work. Therefore, the technician might still need to wear FRC with an arc rating of 4 calories per square centimeter, even though the incident energy level is lower. It's also important to consider the potential for arc blast, which is the pressure wave created by an arc flash. Arc blast can cause serious injuries, even if the worker is not directly exposed to the heat energy of the arc flash. Therefore, it's important to wear appropriate arc-rated head protection and hearing protection when working on energized electrical equipment. In addition to these specific scenarios, it's important to remember that FRC should be inspected regularly for damage. Damaged FRC can lose its protective properties and should be replaced immediately. FRC should also be laundered according to the manufacturer's instructions. Improper laundering can damage the fabric and reduce its arc rating. By following these guidelines, employers can ensure that their workers are adequately protected from arc flash hazards. Remember, electrical safety is not just a matter of compliance. It's a matter of protecting the lives and well-being of workers. Let's delve deeper into the practical aspects of selecting, using, and maintaining flame-resistant clothing, along with some common misconceptions and frequently asked questions. Firstly, regarding the selection of FRC, it's crucial to understand the different types of fabrics available and their respective arc ratings. Common FRC fabrics include treated cotton, inherently flame-resistant fibers such as Nomex and FR rayon blinds. Treated cotton is a cost-effective option, but its flame resistance can diminish over time with repeated laundering. Inherently flame-resistant fibers, on the other hand, maintain their flame resistance throughout the life of the garment. When selecting FRC, it's important to consider the arc rating required for the specific tasks being performed. As mentioned earlier, NFPA 70E provides guidance on determining the appropriate arc rating based on the incident energy level. It's also important to consider the comfort and breathability of the fabric, as workers are more likely to wear FRC that is comfortable and allows them to perform their jobs effectively. Secondly, regarding the use of FRC, it's crucial to wear the clothing properly. This means ensuring that the clothing is fully buttoned or zipped up and that sleeves are rolled down. It's also important to avoid wearing loose-fitting clothing that could come into contact with energized electrical equipment. In addition to wearing FRC, it's important to use other PPE such as insulated gloves, safety glasses, and arc-rated face shields. These items provide additional protection from arc flash hazards. Thirdly, regarding the maintenance of FRC, it's crucial to launder the clothing according to the manufacturer's instructions. Improper laundering can damage the fabric and reduce its arc rating. It's also important to inspect FRC regularly for damage such as tears, holes, or excessive wear. Damaged FRC should be replaced immediately. Now, let's address some common misconceptions about FRC. One common misconception is that FRC is only required for high voltage work. As mentioned earlier, arc flash hazards can exist at any voltage level. Another common misconception is that FRC will completely protect a worker from an arc flash. FRC can significantly reduce the severity of burns, but it will not completely prevent them. The severity of burns depends on several factors, including the incident energy level, the duration of the arc flash, and the type of fabric worn. Finally, let's address some frequently asked questions about FRC. One common question is whether FRC can be repaired. The answer is that it depends on the type of damage. Minor repairs, such as patching small holes, may be possible. However, major repairs, such as replacing large sections of fabric, are generally not recommended. Another common question is how often FRC should be replaced. The answer is that it depends on the frequency of use and the condition of the clothing. FRC that is used frequently or is damaged should be replaced more often. By understanding these practical aspects of selecting, using, and maintaining FRC, and by dispelling common misconceptions, employers can ensure that their workers are adequately protected from arc flash hazards. The topic of flame-resistant clothing and electrical safety is vast, and it's essential to cover some additional points to provide a comprehensive understanding. Let's discuss the importance of a written electrical safety program, the role of qualified persons, and the significance of incident reporting. Firstly, a written electrical safety program is a cornerstone of any effective electrical safety strategy. This program should outline the policies, procedures, and practices that are in place to protect workers from electrical hazards. It should include details on hazard assessment, risk control, PPE requirements, training, and emergency response. The written program should be readily available to all employees, and it should be reviewed and updated regularly to reflect changes in regulations, standards, and work practices. Secondly, the role of qualified persons is critical in ensuring electrical safety. A qualified person is someone who has the skills and knowledge related to the construction and operation of electrical equipment and installations and has received safety training to recognize and avoid the hazards involved. Qualified persons are responsible for performing electrical work safely and for ensuring that others are protected from electrical hazards. They should be trained in arc flash hazard awareness, lockout/tagout procedures, and the proper use of PPE, including FRC. Thirdly, incident reporting is essential for identifying and addressing potential electrical safety hazards. Any electrical incident, no matter how minor, should be reported and investigated. This includes arc flashes, electric shocks, and near misses. Incident reporting allows employers to identify trends, patterns, and root causes of electrical incidents. This information can be used to improve safety procedures, training, and equipment. In addition to these points, it's important to emphasize the importance of continuous improvement in electrical safety. Employers should regularly evaluate their electrical safety program and identify areas for improvement. This can include conducting safety audits, soliciting feedback from employees, and staying up to date on the latest regulations and standards. Electrical safety is not a one-time effort. It's an ongoing process that requires commitment from everyone in the organization. By fostering a culture of safety and by continuously striving to improve, employers can create a workplace where electrical hazards are minimized and workers are protected. Furthermore, it's crucial to understand the limitations of flame-resistant clothing. While FRC provides significant protection from arc flash hazards, it is not a substitute for safe work practices. Workers should always de-energize electrical equipment before working on it, whenever possible. When de-energizing is not possible, workers should use appropriate safe work practices such as maintaining a safe working distance and using insulated tools. FRC should be considered the last line of defense, not the first. The best way to prevent electrical injuries is to eliminate the hazard altogether. By following these guidelines and by staying vigilant about electrical safety, employers and workers can work together to create a safer workplace for everyone. Let's dive into the specific requirements of 29 Code of Federal Regulations 1910.269, the OSHA standard that addresses electric power generation, transmission, and distribution. This standard contains numerous provisions related to electrical safety, including requirements for training, PPE, and safe work practices. One key provision of 1910.269 is the requirement for employers to provide training to employees who work on or near exposed energized parts. This training must cover the hazards associated with electrical work, the safe work practices that must be followed, and the proper use of PPE. The training must be provided initially and then repeated at least annually. Another key provision is the requirement for employers to assess the workplace to identify potential electrical hazards. This assessment must include an evaluation of the potential for arc flash and electric shock. Based on the hazard assessment, employers must select and provide appropriate PPE to protect employees from the identified hazards. This PPE can include FRC, insulated gloves, safety glasses, and arc-rated face shields. The standard also includes specific requirements for safe work practices. These practices include lockout/tagout procedures, grounding procedures, and the use of insulated tools. Employees must be trained on these safe work practices and must follow them whenever working on or near exposed energized parts. In addition to these general requirements, 1910.269 also includes specific requirements for certain types of electrical work. For example, there are specific requirements for working on overhead power lines, underground power lines, and electrical substations. These specific requirements are designed to address the unique hazards associated with each type of work. It's important to note that 1910.269 is a performance-based standard. This means that it sets the goals that employers must achieve, but it does not prescribe the specific methods that must be used to achieve those goals. This gives employers flexibility to tailor their electrical safety programs to their specific needs and circumstances. However, it also means that employers must be proactive in identifying and addressing potential electrical hazards. They cannot simply rely on compliance with the minimum requirements of the standard. To ensure compliance with 1910.269, employers should develop and implement a comprehensive electrical safety program. This program should include a written electrical safety policy, a hazard assessment process, a PPE selection process, a training program, and a set of safe work practices. The program should be reviewed and updated regularly to reflect changes in regulations, standards, and work practices. Employers should also conduct regular audits to ensure that the program is being followed and that it is effective in protecting employees from electrical hazards. Compliance with 1910.269 is essential for protecting workers from electrical injuries and fatalities. By understanding the requirements of the standard and by implementing a comprehensive electrical safety program, employers can create a safer workplace for everyone. To further clarify the responsibilities of employers under OSHA regulations and the guidance provided by NFPA 70E, let's discuss the concept of due diligence and the importance of documentation. Due diligence refers to the reasonable steps taken by a person or organization to avoid committing an offense. In the context of electrical safety, due diligence means that employers must take all reasonable steps to protect their employees from electrical hazards. This includes conducting hazard assessments, providing appropriate PPE, training employees on safe work practices, and implementing a comprehensive electrical safety program. But due diligence goes beyond simply implementing these measures. It also includes ensuring that the measures are effective and that they are being followed consistently. This requires ongoing monitoring, auditing, and enforcement. One of the key elements of due diligence is documentation. Employers must document all of their electrical safety efforts. This includes documenting hazard assessments, PPE selection, training records, safe work practices, and incident reports. Documentation is important for several reasons. Firstly, it provides evidence that the employer has taken reasonable steps to protect employees from electrical hazards. This can be important in the event of an OSHA inspection or a lawsuit. Secondly, it helps to ensure that the electrical safety program is being followed consistently. By reviewing documentation, employers can identify any gaps or weaknesses in the program. Thirdly, it provides a valuable record of electrical safety activities over time. This can be used to track progress and to identify trends. The specific types of documentation that are required will vary depending on the nature of the electrical work being performed and the potential hazards involved. However, some common types of documentation include hazard assessment reports, PPE selection checklists, training attendance records, lockout/tagout procedures, and incident investigation reports. It's important to note that documentation should be accurate, complete, and up-to-date. It should also be readily available for review by employees and OSHA inspectors. In addition to documenting their own electrical safety efforts, employers should also require their contractors to provide documentation of their electrical safety programs. This is important to ensure that contractors are following safe work practices and are protecting their employees from electrical hazards. By exercising due diligence and by maintaining thorough documentation, employers can demonstrate their commitment to electrical safety and can protect their employees from electrical injuries and fatalities. Let us add another dimension to the discussion by addressing the specific challenges faced by boiler operators and maintenance workers in relation to electrical safety and flame-resistant clothing requirements. Boiler operators and maintenance workers often work in environments that present a unique set of electrical hazards. These hazards can include exposure to high-voltage equipment, confined spaces, and extreme temperatures. In addition, these workers may be required to perform a variety of tasks, such as troubleshooting electrical problems, repairing equipment, and performing lockout/tagout procedures. These tasks can expose them to a range of electrical hazards, including arc flash, electric shock, and electrocution. One of the key challenges faced by boiler operators and maintenance workers is the need to work on or energize electrical equipment. This is often necessary to troubleshoot problems or to perform maintenance tasks. However, working on or near energized equipment significantly increases the risk of electrical injuries. To address this challenge, employers must provide these workers with appropriate training, PPE, and safe work practices. The training should cover the hazards associated with working on or near energized equipment, the safe work practices that must be followed, and the proper use of PPE. The PPE should include FRC, insulated gloves, safety glasses, and arc-rated face shields. The safe work practices should include lockout/tagout procedures, grounding procedures, and the use of insulated tools. Another challenge faced by boiler operators and maintenance workers is the need to work in confined spaces. Confined spaces can present a variety of hazards, including electrical hazards, atmospheric hazards, and physical hazards. To address this challenge, employers must develop and implement a confined space entry program. This program should include procedures for identifying confined spaces, evaluating the hazards associated with confined spaces, and controlling those hazards. The program should also include procedures for testing the atmosphere in confined spaces, providing ventilation, and rescuing workers who become trapped in confined spaces. In addition to these challenges, boiler operators and maintenance workers may also face challenges related to extreme temperatures. Working in extreme heat or cold can increase the risk of fatigue, heat stress, and hypothermia. To address these challenges, employers must provide workers with appropriate clothing, rest breaks, and hydration. They should also monitor workers for signs of fatigue, heat stress, and hypothermia. By addressing these specific challenges and by providing boiler operators and maintenance workers with appropriate training, PPE, and safe work practices, employers can create a safer workplace for these essential workers. Lastly, consider the role of continuous education and staying updated with the latest revisions of standards. The world of electrical safety is not static. New technologies emerge, and our understanding of hazards evolves. Therefore, continuous education is not merely a suggestion but a necessity for all stakeholders, from employers to employees. NFPA 70E, for example, is revised every 3 years to incorporate the latest research, best practices, and technological advancements. These revisions can have significant implications for electrical safety programs and FRC requirements. Staying abreast of these changes requires a proactive approach. including participating in industry conferences, attending training courses, and subscribing to relevant publications. Employers should ensure that their electrical safety programs are updated to reflect the latest revisions of NFPA 70E and other applicable standards. This includes updating hazard assessments, PPE selection, training materials, and safe work practices. Employees, too, have a responsibility to stay informed about the latest developments in electrical safety. This can include attending refresher courses, reading industry publications, and participating in safety meetings. By embracing continuous education and staying updated with the latest revisions of standards, we can collectively enhance electrical safety and create a safer working environment for all.